This is a review for quiz 2 in basic kinesiology. We're going to look at the lever and its parts. The lever has three basic parts: an axis, which in the body is represented by the joint. As you know, joints can have more than one axis, so here is another thing you want to be able to make sure you understand. Joints that can do flexion and extension move on a frontal axis through the sagittal plane. Joints that can do ab and adduction move on a sagittal axis through the frontal plane, and joints that can do rotation move on a vertical axis through the horizontal plane. So when we say an axis, it could be any of those on a joint. The next component of a lever is the resistance. In the human system, the resistance is always gravity plus whatever mass we're trying to move. So that represents gravity. And that always pulls down. Gravity pulls down, and we are trying to oppose that with the use of our force. The force that we apply in the body is the muscle. And muscle contraction will oppose gravity, so I'll always draw it as an up. And the axis is generally shown as a triangle. So there's three classes of levers. The first class of lever will have the axis in the center. It'll look like this. And you will have the rigid bar, which in the body, the rigid bar is always a bone. And in one direction, you'll have muscles trying to pull up, force. In the other direction, you'll have gravity trying to pull down. This first class lever is best for balance. Balance, as this looks like a seesaw, is how we would use a lever like this in a playground. In the body, the only example is how we balance the skull on the cervical vertebrae. So you notice it wants to pull forward. We have muscles on the back that will oppose that and hold it upright. So the first class lever, while rare in the body, is used to maintain balance. The center of the first class lever is always going to be the axis. The second class lever, the center will always be resistance. You notice it doesn't matter which way these two go. I could have the skull facing in either direction and I still have the same balance problem. So same with all the levers, it doesn't matter what's on either end. I just want you to look at the center and tell me what's going on there. So on a second class lever, the center point will be the resistance. On one end, you'll have the force, which is opposing it, and then the other end of it, you will have the axis. This is an example in the physical world how we would use a wheelbarrow or even a crowbar to pry in one direction against the resistance in the center around a pivot point that is distal. A great example in the body of how we use this, if we were to stand on our toes, the calf muscle is here, the weight of our body or the resistance is here, but this is the axis that we pivot upon. So lifting up on your toes, using one muscle to lift the entire weight of the body is an example of a second class lever. Second class levers are best for power. Again, not that common in the body. The most common type of lever you'll find in the body system is a third class lever. Third class levers have the force in the center. On one end, we're going to put the resistance, and on the other, we put the axis. But again, it doesn't matter which way I put these two, as long as the force is in the center. These are best for range of motion, and that's why our priority in our body is for most motion possible. This is how a swinging door would work, but in our body, we could use the lifting of our arm by having a resistance down here. The axis is the actual elbow joint. When I place a muscle, I'm going to attach it distal to that joint and pull here. So I gain full range of motion by setting up the lever that way. So a third class lever is the most common you'll find in the body. So for review for the exam, I want you to be able to tell me what each letter spells out. So if I write A, you'll write axis, R is resistance, F is force. The axis is represented in the body by the joint. Resistance is represented in the body by gravity. Force is represented in the body by your muscle. One of these will appear as a diagram. Look at what's in the center, and then be able to tell me what type of lever it is. Then I'll also ask, what is the first class lever best for? Balance. Second class is best for power. Third class is best for range of motion. And which one is most common in the body? Third class. The other items on the test will be a review of this. If you can give us an example of what flexion extension is, that would be very helpful. So sagittal plane, frontal axis, flexion extension. Example would be curling your biceps up, or walking, marching, climbing stairs, you name it. Anything that goes in this direction. Abduction, an example of that motion could be jumping jacks. Oh, that doesn't look good. Or laying on your back doing a snow angel. Those are side-to-side motions. Rotation motions could be shaking your head no, side to side, or spinning around a point. Also, it happens when you do pronation, supination of your forearm. Other things that will be on the test, this is, I think, better summarized there, but you can look at this. Just know that I changed the letters to match my description, so don't get hung up on what it says here, just look at the examples. This is the only other thing that I'll quiz you on from this unit. The difference between an open kinetic chain and a closed kinetic chain. If the chain is open, that means we have free motion of the distal extremity, and that's how we use mostly our upper extremity. If we have a closed chain, we place that distal extremity on a surface, and then we move into it or away from it. So when we walk, we use closed chains, we open them on the right leg to step, close, open, close. So examples that would be given for the exam would be, if I'm leaning on my right hand, reaching for this skull, I have a right hand closed chain, left hand open chain. And that ought to do it. See you next Saturday.